These days, we hear music all the time. It wakes us up, it motivates our workouts, keeps us company on our commutes. It doesn't matter what kind of music it is, music itself has the ability to affect our moods and our bodies in all sorts of ways. We nod our heads, we sway, we dance. Music can give us chills, even make us cry.
Music activates every area of the brain that we have so far mapped. In fact, there's no area of the brain that we know about that music doesn't touch in some way.
But what's behind all that? What exactly does music do to us?
To find out, I went through a whole series of tests designed to measure my responses to music. I met some kids whose brains may actually be changing thanks to those hours of learning, practice, and performing. Spoke with a therapist who used music to help former Congresswoman Gabrielle Giffords learn to speak again, and got a glimpse inside the brain of a 2-time Grammy-winning artist while he played. All to find out how music affects us. So what's going on when we listen to music? We visited the USC Brain and Creativity Institute, where I had my head examined, literally, to try to figure it out.
I'm going to go into this fMRI machine, a tiny tube will surround me, we'll get a baseline reading of my brain, and then I'm going to listen to some music, and we're going to see how my brain responds.
Just close your eyes, relax, and try and get into the music as best you can, okay?
And here's what we saw. These are scans of my brain. The areas in red are where my activity is above average, in blue below average, and as you can see, there's red activity all over my brain, not just in one specific area.
25 years ago, the idea was that language is in the left side of the brain and music is in the right side of the brain. But now that we've got better quality tools, higher resolution neuroimaging and better experimental methods, we've discovered that's not at all right.
How does that play out in different regions of the brain?
When music enters and then gets shuttled off to different parts of the brain, it stops at specialized processing units in auditory cortex. They track loudness and pitch and rhythm and timbre and things like that. There's visual cortex activation when you're reading music as a musician or watching music. Motor cortex when you're tapping your feet, snapping your fingers, clapping your hands. The cerebellum, which mediates the emotional responses. The memory system in the hippocampus, hearing a familiar passage, finding it somewhere in your memory banks. Music is going on in both halves of the brain, the left and the right, the front and the back, the inside and the outside.
So what about a musician's brain?
To play a piece of music engages so many things: motor systems, timing systems, memory systems, hearing systems. There's all sorts of kind of brain activity happening. It's a very robust thing to play music.
I'm Alex Jacob Robertson. I'm Nathan Glenn Robertson.
We asked these 11-year-old musicians to tell us what's going through their minds when they play.
Some of the most important things are having good postures, getting the note right, legato, staccato. For the violin, you need to hold your hand at the right place, and you need to be in tune, and then you also have to have not only the right intonation but the right sound, and then you also need to have great vibrato. There's a lot of things to think about.
Back at USC, researchers have been studying kids who play music over the past 5 years to see how it affects their development. The multitasking areas of their brains understandably lit up, but they've seen other results too.
Music training over the course of 5 years has had benefits in cognitive skills and decision making, also had some benefits in prosocial behavior, and we've also seen changes in the associated brain structures.
Did you hear that? Changes in brain structures. They found that the brains of children who have studied music have stronger connections between the right and left hemispheres, and that can make them better, more creative problem solvers. And then there's emotion. When you hear a piece like this, it's easy to understand why emotions play such a big part in music. This song, by Camille Saint-Saëns, is known as the music for the dying swan in ballet. And while it might move ballerinas to dance, it inspires different reactions in others. Some people get goosebumps, the chills, that weird tingly sensation that you get when a great piece of music just hits you in the right way. It's called frisson, and not everyone gets it. But it turns out I do.
Now we're going to have you listen to some pieces of music.
Okay.
When you experience a chill, if you do, I want you to just press the space bar so we have an indication of when the sort of peak moments of enjoyment are happening. Okay.
Matt Sachs, a PhD candidate at USC, wired me up to measure my physiological response.
So when I'm feeling that kind of emotional connection that has a physical manifestation, we'll see what my body is actually doing.
Exactly.
This is
All right. How was that?
That had a lot of them.
We got them all.
Connection that has a physical manifestation, we'll see what my body is actually doing.
Exactly. All right. How was that?
That had a lot of them.
We got them all.
Now, full disclosure, back in the day, I played the cello, which might have something to do with why that particular song affected me. Nice hair. But it turns out the brain is at work here too.
We process the difference between this pathway that connects the auditory regions, which is on the side of the brain here, to the emotional regions. And we show that the tract actually that connects those two regions is stronger, there's more fibers in that region in the people who get chills.
Which means some people's brains might have better communication between what they hear and how they feel.